Here is Alexei. He began his career as a software developer. A decade later, he realized that breaking code was way more fun than writing code and decided to switch direction. So he is now a full-time application security professional with several years of assisting various development teams in delivering secure code as well as security consulting. He currently works as a senior product security engineer for Salesforce and occasionally speaks at local security events and global conferences.
Thank you. Hi, everyone. Hello. Yeah, last talk of the day. Yeah. All right, let's go. So when I started looking into this topic of deserialization about over a year ago, I thought it was kind of boring. But then I started reading all this information on the internet and realized that, man, that's a lot. It's just too much. So my company asked me to prepare a little educational material for our clients on deserialization, and that's why I started even looking into it. But you know, all this information out there is just overwhelming. And it's just lots of different languages, lots of different frameworks, lots of different ways to exploit and to protect. And they might be very, very specific to a particular system. So today, we're not going to talk about all that stuff. I'm going to give you just a little snapshot, like an overview of what that is. And actually, my favorite part of this presentation is the demos, and I hope they all work. You there in the back of the room, you might want to move closer to see the stuff on the screen. All right, let's start. Just in a few words, what is deserialization? Imagine you have some kind of a program with an object in its memory, and you want to send that object maybe to a different program. So the way it's normally done, that object is converted to a stream of bytes that you can send over any media. And then on the other end, it is converted back from the byte stream to an internal representation of the object. So the first one is called serialization, and the second one is called deserialization. It's a very simple concept. There are some binary serialization formats, and those are normally related to languages that support serialization natively, like Java, Python, or .NET. But there are also human-readable formats like XML or JSON or any XML-based formats where you see this kind of structured data and you can even read it and understand what it is. Of course, this is just a very small subset. In reality, there are many, many more formats. And again, we're not going to talk about them, but you can go to Wikipedia. So with that, let's move to our demos. And the first one is a cookie. So this application is written in Node.js. For my demos, I try to use different languages. So this one is Node.js. And it has two parts. One is insecure. And when we click there, we got a cookie. Here it is. And it looks like a base64 encoded data, right? So let's go and try to understand. I need to replace these two characters with real characters. OK. Decode. All right, it's a very simple JSON object. OK. And what it tells me, and I think you agree that it probably describes who the user is and what their role is. So what if we just replace something, like I'm going to replace administrator, anonymous with admin. OK? Looks better now, right? And I'm going to base64 encode it. And here's my new value. So let me try to give it back to the server. So I'm replacing this cookie in the browser and refresh the page, and now I'm the admin. So very simple, right? It's really basic stuff. But the problem here is that the application doesn't really make any checks, right? It just trusts the user. So when we go to the secure section, we got a cookie again. And it begins in a very similar way, but it's actually much longer. And it actually consists of two parts, separated by a dot here. I don't know if you can see it. But the first part is our JSON, and the second part is an HMAC. It's a cryptographic thingy that you use to authenticate your data. So if I try to replace the JSON and refresh the page, I'm kicked out because that HMAC does not verify. Oh, that's much better. So, of course, no integrity, no security. So go ahead when you think that you're receiving data that might have passed through somebody that you don't trust, always have something that you can validate. Let's move to a more interesting example. I have a Tomcat server that runs, obviously, a Java application. And suppose I want to contract a factory to build something. So I go to factory and order 1 million iPhones. Cool, and they build it like that. So they send me back that package. I'm gonna save it. And then I'm gonna go, so now that I got the items, I wanna sell them, so I'm sending them to the store. So this is the store that sells all the things. So I give them this iPhone package, and they instantly sold 1 million iPhones. And I got the profit. Let's try something else. Tesla, I think 1 million counterfeit Teslas would be too much, so let's dial it down. And try to sell them. And they sold 100 Teslas. Awesome. So let's take a look at those objects and trying to understand them. The file command on Linux tells me that serialized Java data, and that actually is because I wrote it. Is there anything that can go wrong with this? Of course, the answer is yes. So let's say I go the factory, not real factory, but the bad one, the malicious one called Hactory. And instead of iPhones and Teslas, they send me some different things. I'm gonna store them all on the disk, and I'm gonna try to sell them. So again, I'm not the victim here. I'm just passing them through, okay? Well, maybe I don't get the profits, but it's all right. So first of all, I try to sell this string object, and I get a Java exception. Great, right? Because string is not what they expect. And well, they didn't handle exception here, but at least they did not, I did not shell that box. But let's see where the exception was thrown. It was thrown on line 21 of that file. And on that line, we use the Java function called readObject. That's the one that does deserialization. And then we cast the result to the class that we expect, right? The class is called items. But if you read the exception carefully, it says that a string cannot be cast to class items, which suggests that the deserialization actually did occur. We got the result from readObject, and that's where we failed, on casting. So if anything goes wrong, like something really bad goes wrong during deserialization, we're not gonna be able to catch it because it will be too late. So to prove my point, let's try to sell a couple of other things. So the 64 gigabyte nested object, whatever that is, now instead of an exception, I get connection reset, which kind of suggests that the thread just crashed. And in fact, it did, because that little object, and it's really not that large. It's 100 bytes. But when deserialized, the JVM tried to allocate 64 gigabytes of memory, and I don't have that much memory here on this machine. Let's try to sell something else. How about this CPU bomb payload? And I just push the sell button, and I'm not getting anything. It just sits here and does something. So it seems like it's hanging, but but I hear my CPU fan going up. It's pretty loud. So what's going on? Let's go to this virtual machine that runs this Tomcat server and run the top command. And here in the first line, you can see that Java process is using 100% of the CPU. And it will sit here forever. And what is this process? Of course, 17381. It's our Tomcat server. And the only option I have at this point is to kill it. Because it's going to sit there forever spinning my CPU. Let's restart the server if we can. I hope we can. Yeah. OK, it's back. So what just happened? This little object, again, it's just 100 bytes. But when deserialized, it has something in it that tells JVM allocate 64 gigs of memory. And JVM refuses. This one on the left is a structure. It's 100 levels deep. And it's actually a hash set with more hash sets. And it's finite, right? It's only 100 levels deep. But JVM has a huge issue with it. It goes in some kind of an infinite loop, and it will never return. We'll just try to build that tree or whatever. OK, how can we protect? Let's go to our secure store and try to sell those things. First of all, let's try to sell iPhones, and they can still do that. Let's try to sell 64 gig object. And now we got a nice error message saying that Java object is not something that we would sell. Awesome. And same with the CPU bomb. It's a hash set. And we're not going to process hash set. So they actually whitelist the class types that they're going to deserialize here. And they would reject anything else. Cool.
How do they do that?
How
do they know that because you said...
Yes. Yes. The question is, how do they do that? The answer is here. You can override a certain class in Java, and here you can check the name of the class on your input with the name of the class that you expect to see. So that's the recommendation given by OWASP and a bunch of other sources.
So you put extra functionality for it to fail gracefully?
Yes. Yes. There's extra functionality for it to detect and fail gracefully. Return a nice exception that will be this one in this case, and that will be handled. OK. Next one. Well, causing a denial of service might be a great goal, but most of the times we want remote code execution on the server. So let's see how we can do it, in this case, with Python. This is a very simple application, doesn't do much, but it gives me back a session cookie. And what is the session cookie? Again, it seems like a base64 encoded object, and since this application is written in Python, I might assume that it has something to do with Python. So let's see if I can analyze it. I need to base64 decode it first, and I'm going to write it to a file because it's some kind of binary. I wrote it to file, and then I have a little program that deserializes and prints the output to me. So again, it's a very simple Python dictionary, again with some role and username, whatever. And again, I can probably spoof the role here, but that's not what I'm after. What I'm after is, in Python, when you use its standard serialization mechanism called pickle, you can define a class with a method called underscore underscore reduce underscore underscore. And whenever you serialize and deserialize such a class, this method gets executed. So if everything goes well, when this is deserialized, it's going to run OS command. In this case, it's a netcat, and I should get a reverse shell. All right, let's give it a try. This is my payload generator, and generated a Python object, which this application will just accept because it doesn't have any checks. Bad for them. But before I refresh my page, I want to start a netcat listener on this machine. Refresh, go back, and I immediately got a connection from somewhere. And it appears to be a shell. And I am a root, so this application is not configured well either. And I can do whatever I want, right? Unfortunately, in Python, there is no really way to protect against this. So don't use deserialization in Python unless you trust your source. Cool, let's switch gears a little bit and talk about some well-known vulnerabilities in the past years. And when I'm gonna talk about some companies here, I'm not talking about them in a negative way because deserialization is hard. So first one is in Apache Commons collections, which was not really in Apache Commons collections, but it made a lot of noise 4 years ago when somebody found what is known as Apache Commons gadget chain. And when your web application deserializes an object with this kind of chain, and it has Apache Commons library on its class path, we're talking about Java applications, that gadget chain might cause code execution or can do anything else. And here is a sample call stack or call tree of the method calls that occur during this kind of deserialization. As you can see on the bottom, the ultimate goal is to get runtime and call exec. Yeah. So again, like I said, is a problem with Apache Commons? No. The problem is with the web application, which is not deserializing in a safe way. But during those events 4 years ago, big companies pressured Apache project, and they had to fix the library. So they issued a fix for Apache Commons collections, but they made a statement that this is not our problem, we do it, but you need to take care of your applications. Because if any other one of these library X, Y, or Z has similar issues, you're still vulnerable. Makes sense, right? Okay, next one was in Apache Struts a couple years ago. This is XML deserialization, but the payload, this is the payload, which is wrapped in HTTP request, has some Java code in it, and you can easily recognize it. And again, the goal here is to get Java runtime, or in this case, it's process builder, and you pass a string to it and gets executed. Another similar one in Oracle WebLogic. This is SOAP, which is XML based. And pretty much same thing. You get process builder, you execute command. And apparently, Oracle WebLogic had several issues over the years. And if you go to Metasploit, these are all the known exploits there in WebLogic related to deserialization. Like they had one each year since 2015. A lot of fun. Not really. But I hope they got it right. And we're not going to see the next one in 2020. All right, Cyberark is a security product. It's like your enterprise level password manager, which keeps all your credentials safe. And they have a really nice web access API, which is REST API. And of course, it's protected by authentication token. But that token happens to be a serialized .NET object. Nothing wrong with that, really. But they didn't have any integrity protection, meaning you could spoof it. Not just that, they didn't have any class type validation, meaning you could submit any .NET object of any class, and they would process it, which led to .NET gadget chain, similar to that Java gadget chain in Apache Commons, and which led to remote code execution. Somebody found it, and they contacted the vendor, they fixed it, and then the hackers published the exploit, and this is the whole exploit. You run a utility to generate payload, and you run a curl command to send that payload to the server, and that's it. Is it difficult to do? No. In fact, we're going to do it right now. If I can find my window. Okay, I don't have Cyberark, so I had to write my own application. And all similarities are purely unintentional. It's called Cyberark, and it has one REST API endpoint, and when you go to it without any parameters, it just returns a sample value to you. So let's do it from the command line. I love command line. All right, so this is that sample value, which says, hey, this is sample authorization value. So we're going to submit that value as authorization header, if I can find it. OK, here it is. And it processes it and returns the object to us. It says the best. Awesome. But I told you that we're going to exploit it in a real way. So we're going to run that utility called ysoserial.exe. This is actually ysoserial.net, but it's exe, it's executable on Windows. OK. And we generate an object that will supposedly run calc.exe. Every hacker wants to run calculator. And we're going to wrap that payload in authorization header, right here, right? And send it to our application. And we got an exception, like a huge exception, but we got our calculator. OK. So as an attacker, as a pen tester, what are the tools that you can use to try insecure deserialization? So first of all, you might want to reverse engineer things. You probably want to understand what the software is doing and whether it even has serialized objects. And there are certain signatures, like Java serialized object has a certain 5 bytes in base 64 that you can just grab for. Same is true for .NET. There's a tool called ysoserial. It was originally written 4 years ago to generate exploits against Apache Commons collections. I cannot recommend it enough. It's a great tool if you're working with Java applications. Since then, it got a whole bunch of other exploits in different libraries. And I did use it on engagements, and it works really well. A similar tool for .NET, which we just used 2 minutes ago, payload generation for .NET, also awesome tool. There are some burp extensions, if using burp, that will help you analyze serialized data and maybe even modify them and resubmit. And of course, in many cases, you may have to write your own code, which is OK, because you can copy and paste from Stack Overflow, right? So takeaways, deserialization is awesome, well, but it can be dangerous, right? So don't use it. I mean, no. Well, there are legitimate uses. And if you trust the source, OK, you can do it. If you do validation, if you attach HMAC, and you discard anything that HMAC, where HMAC does not compute, then that's fine. OK. But if you do it insecurely, bad deserialization can cause you all kinds of issues, like from broken authentication authorization, privilege escalation, denial of service, and even the ultimate goal of every hacker, remote code execution. And remember, the third-party components can be vulnerable. So even if your program is OK, that little open source cool library might have something in it that is not that good. All this code that I show you today is on GitHub, and you can use it. Feel free to use it. It's very easy to use. You just need to have VirtualBox and Vagrant. And you run one Vagrant command, and 20 minutes later, you have a virtual machine with all this code running, except for Windows. You have to set up your own Windows machine for that. You can contact me on Twitter or LinkedIn, and thank you